Assalamualaikum and hi everyone. In this video, we are going to learn about calorimeter. At the end of the lesson, students should be able to define heat capacity and specific heat capacity. What is calorimetry? Calorimetry is a method used in the lab to measure the heat change of a reaction. The apparatus used is known as the calorimeter. There are two types of calorimeter, which is constant pressure calorimeter called simple calorimeter and constant volume calorimeter called boom calorimeter. This is a sample of simple calorimeter. It is the same as a coffee cup polystyrene. And this is a sample of boom calorimeter. What is a difference between simple calorimeter and boom calorimeter? As you can see from the picture, the process of simple calorimeter is an open to atmosphere. But for the boom calorimeter, the process occurs in a sealed container. The simple calorimeter is used to measure heat flow in a solution, but the boom calorimeter is used to measure heat flow for gases. Simple calorimeter cannot be used for reactions involving gases and high temperature, but boom calorimeter is suitable for high temperature reaction. There is an important terms in this subtopic. Number 1 is heat. The symbol is Q. Heat is the energy that is transferred between objects that have a temperature difference. The unit for heat is joule or kilojoule. Number 2 is heat capacity. The symbol is a capital C. Heat capacity is the amount of heat required to raise the temperature of a given quantity of the substance by 1 degree Celsius, and the unit for heat capacity is joule per degree Celsius. Number 3 is a specific heat capacity. The symbol is a small letter C. Specific heat capacity is the amount of heat required to raise the temperature of 1 grams of the substance by 1 degree Celsius. It is measured in joule per gram per degree Celsius. If the specific heat capacity of water is 4.18, this means that 4.18 joule of energy is required to increase the temperature of 1 grams of water by 1 degree Celsius. This is a various specific heat capacities of several substances. Note that the values of the specific heat capacities of this substance is not necessary to be memorized. Let's look at on the relationship between heat and temperature. So the amount of heat absorbed or evolved by a chemical reaction can be determined by measuring the change in temperature in the surroundings. For that, heat raises or lowers the temperature of the surroundings. If the temperature change is high, so that the heat transfer is also high. So from this equation, we can see that the heat is directly proportional to the delta T. If the delta T is increased, and automatically the heat transfer is also increased. So from these equations, we can deduce the constant C is equals to Q over delta T. So from this basic theory, we have two basic formula. So formula number 1 is Q is equals to a capital C delta T, where the capital C is equals to the heat capacity with the unit of joule per degree Celsius. And the second basic formula is Q is equals to M, a small letter C delta T, where the small letter C is a specific heat capacity with the unit of joule per gram per degree Celsius. Let's look at the basic principle of calorimeter. Here we have a hot water with 90 degrees Celsius and a cool water with 10 degrees Celsius in a thin metal wall with an insulated box. So what will happen over time? So before that, you have to memorize that the hot water or any hot substance will release the heat, and the cool water or any cool substance will absorb the heat. So as the time goes by, the hot water here will release the heat and cause the temperature decrease to 50 degrees Celsius from 90 degrees. And since that the cool water here is absorb the heat, so the temperature increase to 50 degree from 10 degrees Celsius, and eventually the temperature will equalize. So this phenomenon will conclude that the heat released by hot water is equals to the heat absorbed by the cool water, with assumption that there is no heat loss to the surrounding. If we assume that no heat is lost to the surrounding, the energy absorbed inside the calorimeter must be equal to the energy released inside the calorimeter. Okay, so we have these types of formula where heat released by the system is equals to heat absorbed by the surrounding. So heat is use a Q symbol, negative, since that it is released. And this one is absorbed, so positive value Q. So we have formula for Q from the previous slide is M, a small letter C delta T, negative, equals to a positive M, a small letter C delta T. Now we have a hot metal that will be immersed into a cold water. Okay, so as we know that the hot water will release the heat and the cold water will absorb the heat. Okay, so we have the formula of heat released by hot water equals to heat absorbed by a cool water. Okay, so the formula is M, small letter C delta T. So this one is for metal lah, which is hot metal, and this one for a water, which is a cool water. So mass of hot water times with the specific heat capacity of hot metal, delta T, equals to the mass of water times specific heat capacity of water, delta T.